All right, we're back. This is dotnetConf. We are at the 1 o'clock session with Greg Shackles, monitoring your mobile apps in the wild. How you doing, buddy?
I'm doing great. How you doing, Seth?
Fantastic. So tell us what you got, man.
So yeah, today we're going to take a look at some of the why of what you should be monitoring and paying attention to. So yeah, you have some understanding of what's going on in your apps, and take a quick look at some ways you might approach going about it, and kind of showing that it's pretty easy to start getting started and really get rolling with this stuff.
Let's do it, man. I'm excited.
All right. So, yeah, my name is Greg Shackles. I'm a principal engineer at Olo. I'm on the other side of the country from the rest of these guys in New York City. First, it's an honor to be a part of dotnetConf here, and for anyone who's been tuning in for almost 3 straight days now, I'm sure you're getting a little fatigued. So I want to start off with something a little more lightweight. So let's try and tell a little story here. So let's start with what happens after you release your app out into the wild, right? So it's out there. You have thousands or millions of these little minions running around, but then you have to start asking yourself, like, do you really know what they're doing once they're out there? And there's a number of ways that things could be going, and I'm sure that things are probably fine, right? Like, everyone's out there, everyone's having a really good time. It's just riding corgis left and right. Things are pretty good, but humor me for a minute, and maybe things aren't quite so perfect, and I'm probably the only one here that writes buggy software, and the rest of you are all fine. But maybe, just maybe, if you humor me, maybe it's throwing errors, and users are kind of having a bad time when they're hanging out in your app, or maybe they're not hitting errors, right? Like maybe they're a little confused by how to use your app. It might be obvious to you because you're the one that wrote it and you designed the UI and the UX and all of that. But maybe it's not quite as obvious to everyone else. So you always want to maintain a certain level of empathy for your users and kind of make sure that they're getting the experience that you're hoping to give them. But maybe that's not the case either, and maybe everything's working, the users understand what they're doing, but your app is just really, really slow to respond, and this could be one of the most frustrating things about apps sometimes. If you're spending all of your time watching spinners and waiting for things to happen, it gets to be really, really frustrating, and you definitely don't want using your app to feel anything like this game of ping pong here. So what all of this really boils down to when you think about it, it's pretty simple. And it's that, like, if you can't answer any of these questions about your app, if you don't really know what's going on in your app, you're effectively flying blind. And, and this starts with the basics of crash reporting, and crash reporting should really be the baseline that you just can never, ever ship an app without. And hopefully also your apps aren't crashing and you're catching errors, but if users are seeing errors nonstop, like, that's kind of the baseline of what you should be paying attention to here. But then you want to start taking it a step further, and you want to understand the experience that you're giving users and all the rest of how it's performing and how it's behaving. So what I want to do now is go into some slides about what are the types of things that you might want to measure. And this is a pretty well-trodden path when it comes to web development. If you've done any web development in the past, where there's years and years of research and libraries out there and stuff like that around what you should be paying attention to and how to monitor and how to performance test your web applications. But it's still kind of an up-and-coming thing in the mobile space. So let's take a look at some things you might want to pay attention to, like specifically around mobile apps. But we'll start with some that are going to be pretty familiar if you've done any sort of analytics and monitoring. And these are pretty standard things, right? So you want to start measuring the screen hits within your app. And then once you have individual screen hits, you can easily start to map out a user's path or flow through your app and understand how they're really getting to and from different screens, or whether they are or aren't hitting certain screens. But this is kind of really basic stuff, right? And then you can get into some sort of metadata here, like the operating system that they're using, the version of that operating system, the app version, the version of your app. And so you could see if users are actually upgrading or if they're kind of sticking around on older versions. You want to know the main device types and models and carriers and all that of what your actual users are using, because it might be different than what you have in your personal library or what you think that your users might have. And you also want to pay attention to things like how long are they spending inside of your app, and this comes with the obvious context of what your app is trying to do. Like maybe your app is a really quick utility and you want to see that users are in and out of your app within 30 seconds or something. Or maybe this is a more immersive app experience where you want users to stay in for minutes or hours or whatever it is. But if you're not measuring these things, then you really don't know how you're performing in those senses. But those are the really, really basic things. Those are the obvious things that you probably didn't need me to tell you. So let's take a look at some other things that you might want to pay attention to that really get into the meat of mobile apps and how they behave for users. And when I personally set out to try and answer some of these questions for the apps that I'm building every day, this is the key question that I really set out to ask. And what I really, really wanted to know the answer to is, how long am I making my users spend watching a little spinner go round and round where they really want to just be accomplishing something or moving on to the next step or what have you. Like, this is the worst experience for a user other than maybe it crashing or something. So I really want to know, how long are users stuck watching a boring spinner instead of really interacting with my applications? And this isn't really just a nice to have at this point. This is something that users expect and they demand. And this number is taken from a study from about a year and a half ago. And I would assume that number is probably higher if you took that poll today. I mean, the bar for quality in the App Store has only gotten higher and higher over the years. You've got more and more competition for each individual app that you might be doing. And you don't want to give users any opportunity to say, oh, well, maybe I should go look at the competitor's app, because then they might not come back. So things like performance and response time and reliability and all of these things, like, they should be considered part of your baseline feature set rather than nice to haves. So we could take a look at a few things that you could break apart that performance and reliability into a few things. So let's start with what you might pay attention to on the network side, which is pretty key for mobile applications. And an obvious one there is just request duration. So when you make a request out to your server or maybe someone else's server or whatever it is, how long is that request taking? Is it succeeding, or is it failing? Are you having to retry the same requests multiple times, making the user wait and wait and wait just to get that response? Or do you have a high success rate and you only have to make that request once? And then that kind of leads into, well, how frequently are you making requests in general? Like, should you be caching things better, or should you be storing things locally in a local database or what have you? Like, how often are you making these requests? And then how large are these requests? And you have to remember that these are pretty constrained devices and you're on pretty crummy networks. So you really want to know what you're doing to users and how long you're making them wait. And the other caveat to throw out here when it comes to network is that, like, when we set out to answer this question for our apps, like, we already had a really good idea of what our server-side response times were, because we have all sorts of tools in place that really measure that. But the real number that you need to care about, like, that's part of it. But when you start slicing up your performance budget, and if you say, well, let's say I want my service, I want this call to come back within a second, and then you have the overhead of HTTP and all that, and then you have the overhead of these really, really slow mobile networks at times. So, if you're on a 3G network or even a 4G network, I mean, you still have, possibly a 100 to 200 millisecond lag just because of the network that you're on. So that adds to the overall experience. That's still time that your server can't really control, but it's time your users spent waiting. So it's really, really important to have a good sense of, like, are users on Wi-Fi, or are they on 3G or 4G? Like, how long are your users actually waiting for these requests, as opposed to some potentially really nice numbers from your server that aren't necessarily accurate. So then, going beyond just network, like, we can look at other types of performance data that you can measure in apps, right? So one of them that I really like to point to is what I call time to interactivity, and this is really the time. If you imagine the time span between a user tapping your app on the home screen, it launching, and then it loading whatever it needs to do before they can actually interact and start using your application. So even if your app starts up in a split second, but it immediately needs to go download something for 3 seconds, then that's still not a great experience for the user. So you want to get the time to interactivity down as much as you can, just to provide a really nice, snappy experience for your users. And you also want to pay attention to things like memory usage. So these are, these devices are getting more and more powerful every single year. They're they're basically little supercomputers in your pocket that can be easily taken for granted, but they're still a lot more constrained than your desktop machines or your MacBook Pro or whatever you're using to develop. So you still want to make sure that you're not wasting memory and you're not really wasting resources on there. And that goes extra true for battery life too, especially where more and more operating systems like newer versions of iOS and Android are getting a lot better about really battery shaming apps that end up being battery hogs. So users can just go into their settings. They can look at a list of which apps were consuming the most battery in the last 24 hours or the last week. And you really, really don't want your app to be at the top of the list at all. Like that's only going to give the user more incentive to go looking for an alternative, or just say, maybe I don't really need to use this app. And the same goes for database calls too. So you want to have a good sense of how long your database calls are taking, how many are you making, same kinds of things that we were talking about for the network requests on the previous slide. And then that all really plays into being able to build out good caching layers inside of your app. And once you have these numbers and you know the types of requests that you're making and what's taking time and what's not, you can start to build really smart caching layers that won't waste memory, they won't waste battery, but they will be targeted and caching things that are very, very relevant for your users. So all of these things kind of get intertwined and play really well together once you're paying attention. So that's the performance side of things, and obviously you can go really deep into that. Like, this is a pretty high level look at some key metrics you might want to pay attention to, but I do want to spend some time talking about what you can start looking at beyond performance specifically, and when you can get into more behavioral things. So what you also really want to understand, in addition to just raw performance, is how your app is being used and how, like, what users are actually doing when they're hanging out inside your app. So let's talk behavior for a bit. And to me, this is where it gets really, really interesting and fun. Like, I become a data junkie with this stuff, but this is where you can start to define things that are meaningful within the context of your app specifically. So these aren't globally like universal type things that you might have with CPU usage or memory usage or whatnot. You can start to define things within your specific domain that have meaning. And you can start measuring things like, well, how long does it take for a user to complete some critical flow through your app? Like, let's say you're an e-commerce application. This could be, how long does it take from putting something into your basket to checking out? And there are a lot of statistics out there that say, well, the longer or the shorter you make that, the higher the chance of them not abandoning their cart. So you can start measuring things like cart abandonment rate, and you can go as far with this stuff as is meaningful for you, and it can get really addicting, really fun, gives you a whole lot of insight into what's really going on. And along the same lines, you can start measuring things like in-app actions. So in addition to just things like knowing whether they hit a certain screen or took a certain flow, you can start measuring what they're actually doing on those screens. So let's say you add a new feature, you can add an action for that, and then you can start tracking whether users are actually finding that, if they're using it, if it's returning the responses that they're expecting. You can have a real sense of, in addition to what screens they're looking at in your app, what they're actually doing, and understand what they want or what they don't want even. And this is where you get real deep insights into how users actually interact with your app. So you can start answering some of these questions like are they using that new feature that you really love? So just because you put out something doesn't mean your users are going to necessarily love it, or maybe they can't even find it. So maybe you put it out there, no one starts using it, so you need to start trying to feature it more prominently or put in some help hints or something. Like this, if you don't actually pay attention to some of these metrics, you won't actually know, and you shouldn't just assume that those things are working the way you intended when you were in your private testing or what have you. Similarly, these kinds of numbers, especially when you start incorporating things like tracking in-app actions, you'll have a good, meaningful baseline to say, well, maybe I can actually remove some of that old functionality because no one's actually using that anymore, or they moved over to this new feature that kind of encompasses the old stuff. And the last way that you want to find out that you kind of pissed off users and took away something that they really liked is through app reviews, because those are never, ever going to go away. Like, even anyone who claims that they'll you get reviews all the time that say, well, like once you fix X or Y, I'll come back and give you 5 stars. But that never happens. I'm sure they believe it at the time, but trust me, that doesn't happen. So you want to have the numbers to back up how risky a certain change is going to be, as opposed to just waiting for bad app reviews to come in. Similarly, like once you have this steady stream of numbers coming in, you can start measuring that over time, and you could see whether the changes you're making are improving or hurting. Are you making things better for the users? Are your key metrics improving, or are they regressing? Like all of these things start to tie together, and you get a really, really complete story that's easy to see and track across time and across versions and that sort of thing. And then you can, if you want, you can get really, really interesting with this stuff and start doing what's called A/B testing, where you can take a segment of users and split them between two sorts of behaviors. So a trivial example might be, well, you change a button from blue to green and see if that has any sort of measurable impact on user behavior. So do they buy more things with a green button or a blue button? And you can make much more interesting and complex scenarios out of this. So you can use it to introduce new flows or really any sort of change you want to make. And you'll have that baseline and that safety net of measurements coming in, where you can actually see with real numbers and not just anecdotally whether these are having measurable impact across your users and your apps. So that's the whole lot of information about why you should be paying attention, what you should be paying attention to. So I actually want to spend the rest of the time not in the slides, but in going through a demo of how you can start to get your head around some of this stuff, and how easy it actually is to start introducing this into your applications without having to go too crazy from the start. If you're like me, you'll probably go crazy with it in the end, but you don't need to do. It takes very little effort to get a whole lot of benefit. So that's what I want to start showing off here. And there's a few services that I'm going to show as part of the demo here. And the caveat before I kind of list them out and get into it is that I don't actually work for any of these companies that I'm talking about. So I have no financial interest in any of this. All I'm doing here is I want to show off some services that I personally use every single day. And I think they're really awesome, but they're not the only solutions that are out there. So, take all of that with a grain of salt. Like if you want to check these out, I highly recommend all of them, but it's not meant to say that this is the only way that you can go about doing things. So the first one we're going to check out, that if you were watching dotnetConf yesterday, you would have seen a little bit about, is Hockey App. So we'll show how easy it is to add some basic error logging and that sort of thing to your app with Hockey App. And again, there's all sorts of other services out there for this as well. I want to show off an awesome service called RunScope that's really hyper-focused on API testing and API monitoring and basically all things API related. So we'll go into that a little bit. I'll also show some like how easy a service called Datadog makes it to build out really customize and create dashboards and report things and create visualizations in like whatever way that you see fit, which gets really, really powerful. So I'll show off how we can do that. And then along the way, I want to show off, with all of these tools, I'll show how to integrate like all of them working with Slack. And again, none of this will be specific to Slack. You could be using HipChat or Gitter or really anything. Like every service under the sun these days has an API. So you can tie everything up to everything. But what I really, really want to show is that you can really end up with a lot of different dashboards really quickly when you start using all these different disparate services. So the more you can kind of tie them together in some sort of cohesive fashion and have things be a little more bi-directional, the better experience that you're going to have, and you'll have to spend less time actively going out and refreshing dashboards and trying to look for smells when your tools can actually push out to you what's actually going on and when something exceptional happens. So I think that's enough for slides. So let's jump into some code here. So what I want to show is I have a little application here, and with the caveat of it's a very ugly application, so don't judge me based on that. But what I have here is a very simple application of a basic company search. So there's two things that make up this very, very complex application that I'm sure is going to make me millions. So you have a search box. If I type in Microsoft here, you see it'll go out, it'll find a list of companies that match that search term, show you their logo if it has a logo. You could tap through on this to see their website. And that's the extent of the app. So very, very simple. If I come through, I can say Xamarin here, it's get some interesting results sometimes, but it's a basic company search. And if I do this over on the Android side, I can show off, let's say, search for My Echo, which is an app of mine. It looks like we have a crash here. So let me try that really quick on the iOS side. All right, so the beauty of all this cross-platform and shared code is that when you have a bug one place, you have a bug everywhere. So let's take a look at how we might track down this bug and fix it before users get really, really mad that they can't search for this amazing app. So let's jump into code. And instead of just trying to debug all this locally, let's pretend that this is happening with a user that's out in the wild. So let's actually just get that crash report right from Hockey App instead of having to debug anything locally. So to add Hockey App to my iOS app, it's really just a matter of these 4 or 5 lines that are right here. So you give it the app key that you created ahead of time. You say start. I'm telling it to automatically send the error when it gets it. You have other options to say, well, prompt the user if that's the kind of experience that you want to do. So let's just go ahead and build and run this right now. And while that's building, what I can do is I can go over and show that on the Android side. Android is also just a couple lines of code, same sort of thing. Automatically upload the crashes, and then you're good to go. So with just a few lines of code, you'll get that integration. So now if I come over here, we'll type this again. We get our crash. I'm going to pop the app back open so that Hockey App has a chance to get that and send it back to them. And I'm actually going to come over here to the app that I've created. And you'll see that we have one crash listed over here now. So we have one version in there, one crash. And if I search in here, and you can see that actually while we were doing that, I got this message pushed over to my Slack channel that says a new crash came in. And it looks like what's happening here is that we're getting an app2awesome exception being thrown for searching for My Echo. And this happens all the time with our app. It really sneaks into the code base, which is a real problem. But if I click on that, we'll see that I have a line number here. So Hockey App's giving us nice managed stack trace. So it's not you could see the mangled native stack trace if you really want to, but it's giving you the nice managed stack trace that you would be expecting if you're a .NET or a Xamarin developer. And it's saying, well, this is being thrown on search service line 31. And you can see we have the full stack trace down here where you could see everything that's going on. So let's jump to line 31 in the code for search service. And you can see right here, line 31. There's a very, I don't know who did code review on this, but they should probably have a stern talking to. But we can remove that. Let's go ahead and run this again just to make sure that we're working here. So that's going to load up the app. A nice quick startup time. I'm going to search for this again. You can see there's a bunch of weird imposter sites in here, but now we're getting the results that we expected. And we were able to get that information without having to debug anything locally. The error was pushed out to us via Slack and via Hockey, and you could set up other integrations as well. But it really didn't take a whole lot of work to get that information. And when we're in here, we have our native stack trace. And on top of that, if you just look at, if I jump back here, we'll jump back into that actually. Like you can quickly see the number of crashes per day, the top affected operating systems, the top devices that were affected. You could start to get a real visualization and a categorization of the types of users and the types of devices that are hitting any particular error. So you can start really having a good sense of like who's hitting problems. What's the repro case going to be like? Like all of these things are super, super important. And as the Xamarin Insights team is being rolled into the Hockey team, you can expect to see a lot of really cool stuff being added around visualizations and analysis in that sense too. So it's a really, really great way to get started with this. And you can use it as a quick bug tracker and add annotations and assignments and all of that too. So it's really nice way to get started. But I don't want to spend too much time going through Hockey since there have been other demos that go a lot more in depth into Hockey. So let's actually take a look at RunScope next. So what you might have seen is there's this API right here that I'm hooking into an autocomplete API from a company called Clearbit, who's nice enough to put this API up. And whatever app you're building probably has some sort of backing API to it as well. And sometimes it's easy to forget that the apps that you're building have this dependency. So it's important to be monitoring what's happening on your server side. If your API starts throwing errors, if your API starts performing really, really slowly, by extension, your app is going to start performing really slowly or throwing errors. So both sides of the coin here are super, super important. So RunScope actually has a bunch of things in place that can really help make it easy to pay attention to this. And one of them is the ability to run automated, basically integration tests that you can script right through RunScope. You can run assertions and script things and have different steps and all of that. And then they can alert you when something goes wrong. So in this case, I've set up this one test just for the search. If I go to the editor here, you'll see that there's some settings. So you could set up a bunch of settings and environments and interactions and notifications and whatnot. But if we look here under steps, so I only have one step in this, but you can have any number of steps. So you can have, things can interact with each other. You can have multiple steps to the test that you're running. But if you're familiar with any sort of testing frameworks or unit testing and then that sort of thing, then this should feel pretty familiar, where you can define the request that you want to make and the HTTP verb that you want to use, any headers, any auth tokens, query strings, what have you. And you can define assertions. So in this case, I'm saying that the response should be JSON coming back. The status should be HTTP 200. And then the first element in the array should have a name of Olo. So because we're searching for a query of Olo, which is the company I work for, we should expect that to be the case. So if I update this now and I say this should be not Olo, let's go ahead and run that. You can see it's running it right over here. It failed, and we also got a notification right here into our Slack channel that says this API test run completed. It had one assertion passed, one failed. If I tap through to this, it'll bring us right to that failing test, and we can check it out. So if I come over here, you can see that the assertion, as expected, Olo was not equal to not Olo. But you can obviously do much more interesting tests with this, much more interesting scenarios. This is just a super, super basic one. And you can see here that I have this running every half an hour. So you could set these to run on different schedules, run them from different regions of the world, and you could start to get a real sense of how your API is behaving and whether it's working at all without having to do anything. And it can just happen on its own in the background and push out to you when something goes wrong. So let's go ahead and update. We'll make this step pass again. So we'll save this and run it. So that's running. Got another alert here saying that this one ran. It completed. It's successful. And if anyone in that chat room now knows that things are looking a lot better on the API. And one kind of side note that I'll make about alerts like this into rooms in Slack is you definitely want to be conscious of how much noise you're putting into these channels, because it very quickly could become ignored. Like the same way that like everyone who's done email notifications for exceptions on a server or anything like that knows that before long you start filtering those to another folder and you stop looking at them. So you definitely want to make sure that you keep things tuned. And you try to keep the signal to noise ratio in a really good spot. So when something does get pushed out to you, it's a legit issue and it deserves the attention of everyone that's in that room. So what we usually do at Olo, just as an example, is that when things fail, those will always report into the appropriate channels that we have. But it's only the first time that something passes after a series of failures that will post that success. And then any subsequent successes they'll report into RunScope and we can see them there, but they won't be reporting into the Slack channel just because that would just increase the noise and distract a lot of people. So then there's one other piece of RunScope that I do want to show here as well. And RunScope has a bunch of stuff, but one thing that can be really cool is this traffic section that they have. So if I come in here and I'm going to copy this base URL that we have, and I'm going to paste it into here and then take this, what they call a run-scoped URL. And you can see that it's really just, it's a convention-based URL where you're just proxying any requests that you make to it through RunScope. So it's going to go to RunScope, then to your destination, then back to RunScope, then back to you. And this can be a really, really powerful way to get to inject some debuggability and some inspectability into APIs that you don't control. Like in this case, the Clearbit API is completely out of my control. If it went down right now, I'd be out of demo. But I also, like, I can't inspect things on the server side. Like, I have no great visibility into what the requests that are being made or the responses that are coming back. But if I come in here now and I search for Microsoft, that's going to go out. You can see I got a set of results here. And if I switch back to run scope, and I'll refresh this, oh, it just came in. You can see this is the request that just got made out, and the refresh beat me there. So this is the request that just went out. So this is, you could see that, here's the headers and the query string that went out. Here's the response. So you could see all the response headers and the content length and content type and all of that. You could see the response body. So it's really, really a super easy way to just inject inspectability into these APIs that you don't control. It's up to you whether you want to actually ship apps this way. If you have anything sensitive going through a system like this, I wouldn't suggest shipping a public app with it, because you wouldn't want something like a credit card number or even PII sort of sitting on someone else's server. You want to be in control of all that information for your users. But at least as a diagnostic utility for your own testing, it's super useful. But it's also been, personally, it's been reliable enough where they haven't really gone down enough for me to be able to say, well, you definitely can't ship an app with them in your critical path. It's kind of up to you whether that's a risk that you want to take in your app. But at the very least, I wanted to show it off as a really great debugging tool for APIs even APIs you do control, but especially for ones that you don't, without having to modify anything other than the URL for something. So that's kind of the run scope side of things. And then what I really want to show now is like how some ways that you might start taking a look at some custom instrumentation and custom monitoring and custom analytics. And there's a whole host of tools that are out there for doing this out of the box. I mean, you can use things like Google Analytics, or Raygun just launched a mobile version of their Pulse offering that gives you real user monitoring for your apps. You can use Hockey App for this as well. So Hockey App does have event tracking in addition to just distribution and error tracking. But since a lot of that was already covered, I did want to show how at Olo we built out a whole bunch of custom instrumentation without a whole lot of work that feeds into dashboards that we can control and that sort of thing. So there's a few things that we can monitor for doing this. So the first thing that I want to do is I want to be able to measure the length or the time, the duration of every network request that's going out. So this is going to be every call out to that Clearbit API. And let's go back to not having run scope in the middle there. And what I'm doing is I'm using HTTP client here, which at this point most people should be using in basically every app that's doing HTTP requests. But one of the really nice things about HTTP client is you can inject some behavior into the pipeline of every request without having to change the interface at all. So what I'm going to do is I'm going to add this instrumented client handler that I wrote right into the middle, and then nothing else that's using this client object actually has to change. And we can take a look at what this is doing, and it's really not doing much. So you can see that this handler is just overriding the send hook in that pipeline. And it's just wrapping the request that would already be made with a stopwatch. So it's starting a stopwatch right at the beginning. It's keeping track of whether the request was successful. And then when all is said and done, it stops the stopwatch and then logs a metric to this metric service here. And that's really the extent of what this is doing. So it's not really adding any noticeable overhead to the application or to the requests. One thing that you definitely want to pay attention to when you're starting to instrument your code is you don't want to make things noticeably worse just so you can measure them. So just as a sort of aside, like when we were first starting to experiment and introduce some of this stuff, like what we actually did was put together a little Xamarin app that just like in a tight loop ran a whole bunch of times the types of code that we were going to start wrapping the types of timing code we were going to start wrapping existing code in to see how long it would perform. And then we actually sent that out to Test Cloud, Xamarin's Test Cloud, and ran that across all sorts of devices. So, really high-end devices, really low-end devices, and then quickly got a good sense of how much time and how much overhead this instrumentation code was going to add. And the end result was that it wasn't going to add anything noticeable, especially on top of something like a network request that already has a sizable overhead to it. So we were pretty comfortable rolling this out, but it is something to always kind of be aware of. So that's the only change that we need to make there, just to start monitoring all of our network requests. And then the other thing that we want to do is there are basically two actions here, right, in the app, right? So you have the act of searching, and then when you're searching, the query that's being searched for is interesting information. And then when you select one of the companies that comes back, that's another thing that we might want to track, so we can have a sense of what people are searching for and which companies they're actually selecting when they get that list of results. So let's go in here, and I'm going to call into this metric service again, and I'm going to say log, and we're just going to give it a new metric, and I'll show these classes in a second. All of this code is actually already available, by the way, up on my GitHub account in a repository called Xamarin Instrumentation Sample. So all of this is already 100% open source. So what I'm going to do is I'm going to give this a key of find companies, count of 1, create a new list, and in this list we're going to pass in the query. So that's all the code that we actually need in this particular spot to log that this query was searched for. And then the last thing we're going to do is run into search page here, just because this is a nice easy hook into where it's happening. I'm going to copy and paste a little bit so that you don't have to watch me type everything here. We'll call this view company, and we'll give this name, and then let's just send in the company name here so that this shows up nicely in our stats. And there's not a whole lot of interest going on in this metric service. All it's really doing is queuing up a set of metrics and flushing at a given interval. For the sake of this demo, we're flushing every 10 seconds. I really wouldn't recommend shipping an app like that, because that's going to be a whole lot of, we talked earlier for a while about how important it is to tune network requests and all that. So you want to be pretty conscious of this. Somewhere around a minute or 2 minutes or whatever makes sense for your app is probably a much better idea. But for the sake of a demo, I also don't want to make everyone wait and twiddle your thumbs while you're waiting for the demo to come together. But then other than that, it's just flushing things out to this API. And the API is something I have run locally, and it's pushing out through a statsd interface to a local Datadog agent here. So this is going to the API. In the case of what we're doing at Olo, it's just a built-in part of our API that our apps are already talking to that accepts those metrics and then flushes those out into our Datadog account. So there's a couple hops there, but it's not too bad. So let's build this. And then let's take a look at what this actually ends up looking like in action here. So I'm going to run this. And we'll pull up the iOS app first. And let's just start by, let's enter a bunch of things so that we can queue up a whole bunch of metrics that we should hopefully be able to query in a minute. There'll be a little bit of a delay for things to start showing up, since it'll be 10 seconds or so before it gets flushed to the API, and then probably another 10 seconds maybe before it gets flushed out to Datadog. And then hopefully that's behaving so that we can start to see data very quickly. It's usually very, very, very reliable in real time. Just search for that. Now let's jump over to Datadog here. So what you have, there's a bunch of things that you can do in Datadog, but we'll start by looking at this metric explorer here. So if I search for dotnetConf, you'll see that there's a bunch of stats kind of coming through. So for the API calls, we can look at the average duration, the 95th percentile, the count. Let's start with the count. We want a sum here instead of the average. And we could see that there's already data starting to come in, and you could tweak your time window and all that. You could see data already starting to come in just based on what we were just doing. And then you could start to split this up by all the different tags that you were sending in. So in the case of those API calls, we were tagging them by the URL that it was trying to hit. You could see that there's the host here, which is the host of the API in this case. We were also tagging every metric that was coming through with the operating system, so splitting between iOS and Android, whether it was successful or not. So you could really start to dig into this stuff. And I could search for You can do view company. You could split that over the different names of companies that you might search for or that you might be viewing. Really, really interesting. And you can query all this stuff in real time, which is super powerful. But what I want to show is a dashboard that I put together that's already made that shows just the really basics of how you might start visualizing these things. And I wish that I could actually show some of the dashboards that we have at work, because you could start to really tailor your visualization and the things that you care about in your system. You can visualize them in a way that gets so much easier to quickly see when there are problems, quickly get the pulse of your system, the how your application is feeling and behaving very visually without having to like dig through things or query your database or anything like that. But you could see here, just in this really simple dashboard, that we have a sense of the average response time of all these API requests going out, the number of API calls that are being made, which ones are the slowest. We only have a couple API calls here. You can also see that the metrics call is itself instrumented, which is super, super important because, like I said, you want to have a good sense of how much overhead your applications are adding just by instrumenting, just by the mere fact that you're instrumenting them, right? So by instrumenting the metrics call, you'll have that sense. And that's using the same HTTP client handler that I showed before in the service. So it's the exact same code. No extra code had to be written, and you kind of get that for free. And you can see which API calls are being made most frequently, split them up by platform. You can get a nice top list of the top search terms that are being made. So you can, like I said, you can define you get a nice real-time view or something very, very close to real-time without a whole lot of work here, and you can split it up. So let's spin up the Android app to get a little more color into the data here. So we can spin up this Android app, and this should be a nice fixed version with the bug fix from earlier. Let's get this back in the background. So let's do some searches here. Have some imposter OLOs, some real OLOs. Tap through here. See a familiar face in the top right. We'll come back. And after a little bit, this data should start kind of coming through. If we're lucky, we might get some already, but if not, within maybe 20, 30 more seconds, we'll start to get some stuff in here. But it's pretty easy to see how quickly you can start visualizing some of this stuff. And there's a whole bunch of other types of graphs that you can do. So you can do straight up query values, time series. You can put multiple things on a graph like this. You can do a top list, which is what this is right here. You could see change over time. So you could do day over day, week over week, month over month. There's just a whole bunch of different visualizations that you can do. And basically, you can customize it to look or behave like most visualizations that you might want to do. So distributions, changes, heat maps, really like anything statistical like that, you're going to get it. And you can see that Android just popped in here without me even hitting a refresh on the page. So this is all just kind of coming in real time, and you get a really nice sense. And you can also do things like set up monitors. So you could say if my average response time of my API goes above 600 milliseconds or something, then I want to send an alert out to PagerDuty or to Slack or send an email. You get all those types of hooks, and you can really start to build out a nice life support system for your entire system here. And you get integrations with all the different server applications and Azure and AWS and all of that. And before we kind of complete this section here, I did promise that every service that I showed, I would show Slack integration with, and I haven't shown that quite yet for Datadog here. So what I'm going to do is I'm going to come in here to my Slack room, and I'm going to invite my good friend ConfBot. So this is an instance of Hubot, and Hubot might be something you're familiar with, where it's a library put out, or it's an application actually put out by GitHub. And it was kind of one of the first big quote unquote bots in like this chat bot revolution that's kind of taking over the world right now. So I can't really do a talk without having some so-called chat ops in here. So first, let's make sure that ConfBot understands the rules of the game here. And it looks like he's got that down pat. So let's show off what it would look like to actually ask ConfBot here, what's going on in Datadog right now. So what I'm going to do is I'm going to come in, And you can really quickly visually build your queries through their interface here. But once you have your query built, there's actually a query language behind the scenes that I wouldn't suggest writing any of this manually. But if you jump into the JSON section, you can quickly copy and paste out the query as their system understands it. And then what I'm going to do is I'm just going to say DD for Datadog. You can write out the whole thing if you want to. I'm going to say query and give it that query. There's a little bit of a built-in pause for one, just to make me feel really nervous during every talk, but two, just to give Datadog some time to do that query. But you can see that right here, right within our chat application, we have that graph that we just looked at over in the dashboard. We didn't have to leave Slack. Maybe some other smell came in and we were like, oh, well, let's quickly check on the API time, and you could do that right through here. But there's also some conversational aspects to this too. So I could say, save that as average API time here, right? So it's saved that. So now I can say query, let's say last 5 minutes API time. It's going to go back. It's going to run that same query, except it's going to be for a duration of the last 5 minutes, and we'll get that. And so let's go and let's add one more here. So I'll come in. Let's do the number of API calls coming in. So we take this long query that, again, you wouldn't really want to write by hand. Say query. That'll come back. Looks like the link didn't feel like working. Okay, so it's Slack's fault that didn't work. But what we're actually just going to do is say, save that as API calls. And now we can call that on demand anytime we want without having to remember any of that query language or any of that stuff. I could say conf.dd list. We'll see a list of the API calls that we have. You could say delete API calls. And it helps if you spell chat ops commands correctly. So do that. And that's kind of the basics of what's in there. We're not going to get that image to work. There we go, much better. Confbot's trying to get in the way of my demo here. So this is all that Datadog interaction there is really just a simple Hubot script that I wrote to interact between Hubot and Datadog. So it didn't take a whole lot of work to kind of make those things work together, since everything has an API, like I was saying earlier. And then that's actually, if you want to use that and you have an instance of Hubot running, you can just install that. If you search my blog, you'll see some more details on it. It's up on NPM, so you don't have to mess with code or really do anything. You can just install the package and it'll just work. The source is all up on my GitHub. Like I said, there's not a whole lot going on in there. But really, this is all just to say that you can start tying all these tools together and make it a much more bi-directional line of communication, rather than having to go out and search in your Hockey app dashboard, your RunScope dashboard, your Datadog dashboard, and at Ola we use all sorts of services. So there's New Relic, there's Pingdom, there's all these things, and it can become pretty overwhelming at times. So the more you can make for a cohesive experience and a cohesive view into all of these different things that are monitoring your system, the better experience you're going to have. And that's all I really have for content here. So, I mean, we can open it up to questions, or if not, I hope you have a great rest of the conference.
Well, I do. I love the way, for me, the thing that you said at the beginning was probably the most interesting, and you said the term performance budget. Because I never thought of it like that. Because, at the beginning of the month, you're like, this is how much money we're going to spend. We have to have this for rent. We have to have that for whatever. I like the idea of actually, implicitly saying, if I'm going to spend 1 second on a request, where should I allocate the time? How have you found it? I mean, how do you allocate that kind of stuff in your experience?
Yeah, and I'm glad you brought that up. It is something worth digging into a little bit. And this applies, well beyond just mobile apps too, where especially on the web, it gets really, if you pop open your dev tools on sites, you'll see an internet full of people that are not paying attention to what I would call a performance budget, where, if you're building things correctly, and especially in the mobile world where, the number of connections matter that you're making and the size of those connections matter, you want to be able to say, okay, I want to take maybe up to a megabyte is fine. And even that's kind of pushing it, but with modern JavaScript frameworks, sometimes that becomes half your budget just in itself.
Right.
But then once you add in like a couple fonts, maybe, then that takes up another, maybe 100 to 200K. And then your API requests start to take up a certain amount. So I don't know that I've found a silver bullet as far as a number goes, but I do like it is good going into these conversations with some context of, well, like what's the baseline of the things that we're requesting? How can we get those down? Like how can we maybe make some concessions in design or experience or and that sort of thing to say, well, once you get above maybe, well, this fonts are more of a thing on the web side than they are on mobile apps where you would kind of ship the fonts in there. So that might not be the best example for an app talk, but maybe the number of requests that you're making. And then you start subtracting out things like an estimated overhead of, say, 1 to 200 milliseconds for your 3G to 4G network, which can sometimes be even worse, honestly. And then maybe a couple hundred milliseconds for your server to respond, which is still a pretty fast API at that point. And then you're already up to about half a second, and that's when everything's working perfectly. So it's definitely worth going into it with that in mind and knowing that it's the complete round trip that really matters there, and not just the little piece on your server or just the little piece of processing on your app, and which is the other part actually too that I didn't mention. So once it kind of goes to the server, it comes back. Your app still needs to do something with that, right? So the amount of time that you spend, say, processing JSON that comes back and updating your database and whatever your app might be doing based on that response still plays into that round trip. The user doesn't really care which parts were spent waiting for HTTP to come back and which were waiting for JSON to come back. Like the user just cares how it behaves and that it's snappy. And you can also start being really clever with how you do certain actions too, where if you know an action's probably going to work, you can sort of, in many cases, you can have your app start to proceed as if that worked, and then make sure that down the line in the flow, you give them some sort of notification or a way to fix any errors that came up. And historically, Instagram has been a really, really great example of this kind of level where after you do your initial edit on the photo and it starts uploading right then and there up to their servers, since most people aren't going to go back and re-edit their photo, but they're going to spend a couple seconds typing in a description or tagging their location or tagging a person or all that. And while they're doing those actions, the really heavy lift of that image upload is going on in the background, so that once they finally finish writing what they were going to write and they hit submit, it's actually already uploaded. The operation is basically complete, and they get instant gratification of that post. So once you start to really understand where the pain points are and where the heavy lifting parts are, you can start to kind of cater your user experience around that in pretty clever ways.
The second question I have, and you kind of talked about that when it came to sort of how they optimize performance on Instagram, is how much of the performance sort of bleeds into the behavioral patterns. I mean, if you know the behavioral patterns and you know that there's some heavy lifting, is there some performance optimizations you can do based upon the behavior patterns?
Yeah, and I think that kind of goes in hand with that Instagram example where, I mean, you're in many ways, like the most important performance metric is perceived performance, right? Like it's just like how if you ship an app and there's a bug in it, a user's not going to care if you say, oh, well, all my unit tests passed, so you must be wrong. Like, they're not going to really care if you say, well, I optimized, X, Y, and Z, and all of those pieces were really fast. If from the user's perspective, they're tapping through it and they're being made to wait, or it's laggy or jittery or what have you. So it really is the ultimate metric for that is perceived performance, and having all this data come in to know that maybe users always take a certain flow through your app, so you can leverage that in clever ways to start doing background operations, or you can maybe prefetch certain things based on what they're very likely to go do next, so that they're not spent waiting. So, and that's where all of these, like having this pipeline of metrics coming in and really having a deep sense of what's going on in your apps and how your users are actually interacting with it, can be something that you can start leveraging and really using to make that experience even better.
So you mentioned performance budget, behavioral patterns, and then you mentioned a series of tools that you like to use, like Hockey App, RunScope. You also did some inline HTTP client handlers. Are there any other performance sort of tools out there that you might suggest to someone building these kinds of applications?
Yeah, and especially like a lot of what I want to show off today is stuff that you would use to monitor apps kind of once they're already out there, but there's still a lot that you can do while you still have control of the app and locally. So I mean, if you're running things locally, then especially if you're doing things like monitoring or memory management and battery testing and all of that, that's a whole lot easier to do if you're running your apps locally. So running them through profilers, so like Apple ships profiles, Google ships profilers. Xamarin has some really nice profiling tools for iOS and Android that really understand the managed runtimes, which is something that you don't really get if you're using the normal quote unquote native profilers that Apple or Google or some other companies might ship. So I definitely recommend checking out the Xamarin profiler. You can also hand roll a whole lot of stuff. So you can write timing code, or I've used a library called Fodi for this a bunch of times, where you can have it automatically start wrapping timers around methods and doing things like that. So that's probably where I would suggest starting with a lot of that stuff.
Well, this is fantastic. Greg, do you have a slide that has your Twitter handle or something? We can get you.
I do. I probably should have gone to that before starting this questions, but we can.
Let's do it. That way people can get a feel for who you are and what you do. Greg, this has been fantastic, bud. Thanks so much for spending some time with us.
My pleasure. Thanks for having me.
All right, so this has been Greg Shackles on monitoring your mobile apps in the wild. Coming up next, Stacey Hafner on introducing C# developers to building games with Unity for the mobile developer. We're pretty excited. We will see you after the break.